The purpose of this video is to teach you how to use the probability functions on your TI-83 or 84 graphing calculator. We'll find all the functions that we're going to be studying when you hit the Math key and move over to the probability menu. The first one we're going to look at is the Factorial key, which would be number 4. But what you don't want to do is to actually click the Factorial right away. You want to enter the number first, in this case 3, go to Math, go to Probability, then choose the Factorial. This will represent 3 times 2 times 1, which will produce 6. If we're going to find 5 factorial, press the 5 first, hit the Math, over to Probability, down to Factorial, then hit Enter. This will be 5 times 4 times 3 times 2 times 1, which is 120. It's a lot easier to do 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 as 11 factorial. A factorial I specifically want to point out is 0 factorial. By definition, it's 1. We need it to be 1 to do calculations, specifically when we get to permutations and combinations, which leads directly to the next probability function, nPr, or permutation of n objects taken r at a time. A permutation is where the order of the objects matters. So if we're going to compute 5p3, we need to put the value of n, which in this case is 5, first. We'll hit Math. We'll move over to Probability. We'll move down to nPr, and then we'll put in our r value next, which is 3, hit Enter, and we'll come up with 60. Let's practice this again. N is 8. We'll hit Math. We'll move over to Probability. We'll move down to number 2, nPr. We'll hit Enter. We'll put in our r value of 6. We'll hit Enter. We come up with 20,160. Let's say you had 11 objects. We'll put 11 in. And you choose to take 0 objects at one time. How many ways could that be done? If we go and put in nPr and then type in 0, there literally is one way to pick 0 objects out of 11. On the other hand, if I had 11 objects and I would like to select all 11 objects at once, and the order of those objects mattered, I would come up with 11p11, which would be typed in the calculator like this. And you would find out that that's 39,916,800 different ways, which not so coincidentally happens to be the same as 11 factorial. Because think about it. If you happen to have 11 items, you could pick 11 first. That would then leave you 10 items next, followed by 9 items, followed by 8, all the way down till you had one last item. And so it would produce, again, 39,916,800 different ways of selecting those 11 items in order. The last probability function I'd like to look at is nCr, or a combination of n objects taken r at a time. A combination is where you take a group of objects and the order does not matter on how you take those. So if I was to compute 5c3, let's again follow the same process we did before. We put the value of n first, which is 5. We go to Math. This time when we go to Probability, we're going to select option number 3, nCr, but we'll still put our r value in afterwards, which is 3. This time we'll come up with a value of 10. Again, 8c6 would be 8, Math, over to Probability, down to nCr, hit Enter, put in the 6, hit Enter. 8c6 is 28 is a very different value than 8p6's value of 20,160. If we're going to do 11c0, or let's say take 11 objects and take 0 at a time, it would not make a difference if we used a permutation or combination in this particular case, because if we take 0 objects at once, there still is only one way to do it. But if I now had those 11 objects and I wanted to take all of them in one big group, I think I just kind of gave away the answer. There's only one way of selecting a whole group. Since order does not matter, it does not matter if object A comes first or comes last or somewhere in the middle. It will still be one way. And this is how you compute n factorial, permutations, and combinations using your TI-83 and 84 graphing calculators.